Good morning, dear student. Today, the topic of this lecture is electric potential of system of charges or group of charges, or in other words, it is also known as superposition principle of potential. So let's see what is the superposition principle of potential. So first of all, we will see the statement, and according to the statement of superposition principle, it is superposition principle is basically used to find the potential at any point due to more than two charges. If we all know that, first of all, let's see what is the statement. The net potential, see here, the net potential at any point due to n discrete charges is equal to the algebraic sum of their individual potential at that point. We all know that suppose this is a Q1 charge, so when it is placed over here, it starts radiating its electric field, and suppose we need to find out the potential at point A, which is r distance away from the Q1 charge. We have already derived the expression for this in the previous video lecture. So the potential at any point, which is suppose r distance away from the charge, any charge, it is equal to the amount of work done to bring Q naught charge from infinity to that point. And when we divide, this work is suppose known as omega, and to bring the charge from infinity to point A. So to infinity to point A, to bring Q naught charge, this is the test charge, Q naught charge from infinity to point A, that amount of work done is given by suppose omega or W infinity to A, then potential is defined as VA, that is potential at A, is equal to work done to bring Q naught charge from infinity to A divided by Q naught. That means work done per unit charge is called potential at A. So that we have already derived that must be equal to KQ1 by R. In this case it is R, so we can write like this, KQ1 by R in this case, because the potential and the point A is R distance away from this. So KQ1 by R is the potential at A. So this is the potential. If we want to find out the potential at a point which is say for example r distance away from the charge, source charge, then we can find out easily the potential at A. This we have already derived in the previous lecture. Now today we are going to discuss superposition principle. If there are more than 2-3 charge, then how can you find out the charge? So this is the topic of this today's lecture. Say for example here you can see this is another system in which you can see this is the source charge Q1, and this is the point A where we have to find out the potential, and there are two more charge Q2 and Q3 also are there. Then how can you find out the potential? And according to the superposition principle, the voltage at A at this point is the algebraic sum of voltage due to Q1, voltage due to Q2, or voltage due to Q3. That means it can be, we can write like this, the voltage, total voltage is the total voltage is given by voltage at A due to charge 1 Q1 plus voltage at A due to charge Q2 plus voltage at A due to charge Q3. So this is the statement of the superposition principle, and it can be extended to any number of charges up to n charges. From 1 to n charges you can extend this expression. So how we can find out the total potential? See here. Here you can see that there are three charges, Q1, Q2 and Q3, and we need to find out the voltage at A. What is the total voltage here? And the Q1 charge is R1 distance away from point A, it is R2 distance away from point A, and it is R3 distance. Q3 is R3 distance away from point A. Then potential at A due to charge Q1 is given by K multiplied by source charge, that is Q1, divided by the distance between A and Q1, that is equal to R1. So the voltage at A1 and that voltage at A due to charge Q1 is given by this expression. And in the same way, voltage at A due to charge Q2, it is represented by VA2, and it is K multiplied by the charge, this charge Q2, and divided by the distance of point A from the charge, that is R2. So this is VA2. In the same way, we can find out this is charge Q3, and due to this charge the voltage at A, that is VA due to Q3, is given by K multiplied by the charge Q3 and the distance between A and Q3, that is R3. So these are the individual charges, and if we want to find out the total potential, these are the potential due to individual charges. These are the potential due to individual charges, and if we want to find out the total potential here, then it must be equal to the algebraic sum of this, this and this. So this is the statement of superposition principle. So see here, this is the total potential. We can easily find out the total potential is equal to, that is Vt, is equal to algebraic sum of all the three charges. If we put the values over here, then we will find, if we put the values, we have already derived this values, kq1 by r1, kq2 by r2, kq3 by r3, and we can here we can find out, we can take out k as it is a common in all the three, so we can take it out, and in bracket q1 by r1, q2 by r2, q3 by r3, or in a very compact form. So this is the total voltage at point A due to all the three charges. So in a very compact form we can write Vt, that is the total voltage at point A, is given by K, and this is the summation of sign. The summation sign is here. I is equal to 1 to 3 because there are three charges, and Qi, this is 1, this is 1, this is 2, this is 2, this is 3, this is 3. So Qi upon Ri. If I is 1, then R is also Q1 upon R1 is I is equal to 2, Q2 R2 plus I is equal to 3, and Q3 upon R3. Up to 3 we have to go. Now for n number of charges, the same expression can also be written as K summation sign I is equal to 1 to n Qi by Ri. So this is the superposition principle, and it is used to find the potential at any point due to number of charges, n number of charges. If we want to find the total potential at any point due to number of charges, then it is algebraic sum of all the charges. It is a algebraic sum of all the charges. So this is the statement of superposition principle of potential. Now this is the question. We have to use the superposition principle here to find the potential, electric potential at point P, which is located, this is the point P, which is located at position B, A, that is B is the x coordinate and A is the y coordinate. As you can see here, this is B, this is A, so this is also A, and this is also, this is B, this is A, because this is A, both are same because it is a rectangle, opposite side are equal. So if this is A, this is also A, this is B, this is also B. So if this is A and this is B, then we can easily find out A is, this is equal to A is under root A square plus B square by we can find out by using Pythagoras theorem. So this distance is under root A square, this distance is under root A square plus B square, and obviously we need to find out the potential at P due to this charge, due to this charge, and due to this charge. So we can find out all potential at P due to Q1 charge, due to Q2 charge, due to Q3 charge, and then individually we algebraically, if we add all these charges, then we can easily find out the total potential at this point. So the formula is here, R1, R2, R3, Q1 is here, and the distance is from here to here is B, and the value of B is given in the question, that is 6 meter. B is 6 meter, it is given here, B is 6 meter. And in the same way, Q3 is A distance away and A is also given, it is 8 meter. So the value of Q3, that means this is suppose R3, so this is equal to 8. So this we know, and R2 we have to find out. R2 is equal to under root A square plus B square, and it comes out to be 10. You can easily find out with the help of 8, square of 8 plus square of 6, that is equal to, it is equal to 100 under root of 100, that is equal to 10. So the value of this is 10. Now if we put the value of K, that is the value of K is K is equal to 9 into 10 to the power 9. We can put here. Q1, we all know that Q1 is given in the question, and Q1 is 1.5 microcoulomb. So Q1 is 1.5 microcoulomb. So Q1 is 1.5 microcoulomb, or you can write 1.5 into 10 to the power minus 6. In the same way, Q2 is also given, and it is Q2 is equal to 2.5 microcoulomb. So that is equal to 2.5 into 10 to the power minus 6 coulomb. This is also coulomb. And the next is Q3. So Q3 is given by, Q3 is minus 3.5 microcoulomb, and that is equal to minus 3.5 into 10 to the power minus 6 coulomb. So if we put all the values over here, and K we all know that 9 into 10 to the power 9, Q1 is Q1, Q2, Q3 we have already I have already discussed what are the values and how because it is given in microcoulomb, so we have to convert into coulomb, and it become 3.5, 2.5, 1.5 into 10 to the power minus 6. A and B we have given in the question, and this we have already computed. So when you put all these thing here, then the potential at point P is the algebraic sum of all Q1, Q2, Q3, all the potential. So that comes out to be Vp is equal to 562. You can verify it. And now the next is the question for you, student. This is the question. It is consider the system of three charges, and it is given in the question. And V is equal to 0 at infinity, as we all know that by the definition. What is the electric potential at point C? That means we have to find out the electric potential at point C, here at the center of the triangle. Q1, Q2, Q3, all the things are given. D is the distance between, that means it is an equilateral triangle, and you have to find out the potential at point C. So that's it for today. Thank you. Have a good day.